Okay, binary probabilities are the kind of probabilities that occur when we have something that occurs regarding coin flips or something equivalent to coin flips. One thing equivalent to coin flips might be, let's say, the number of ways to get so many girls out of so many births. For example, let's say a woman has 14 children. That does happen. And only 2 girls. How many ways are there? She could have had 2 girls out of 14 children. The rest being boys, of course. Okay? Well, it's as if there's a 50-50 chance. Now, let me say that if a woman has 12 boys on 14 births, she's probably genetically predisposed to produce boys, or her husband is. But if we assume that the occurrence is 50-50, then each child will occur as boy or girl, equivalent to flipping a coin. Okay, when the gender of the child is determined, it could be boy or girl, and it's equally likely as it would be if you flipped a coin. So, how many ways are there? Well, if you think of 14 slots for boy or girl in each slot, the number of ways you could get 2 girls would be the number of ways of picking 2 of those slots out of 14, equivalent to just getting 2 heads out of 14 flips. Now, you're asked in the problems to list the subsets of the sets AB, ABC, and ABCD. This is another situation that can be modeled by coin flips, but in a little less obvious way. So you should list those if you haven't already, or if you don't know very well how to make that list. Now I'm going to go ahead and skip to, let's say, the set ABC. What are the subsets of the set ABC? Well, I'm going to list the subsets in order of the number of elements in the subset. There is the empty set, which has no elements. That counts as a subset. And then there's the sets consisting of A, the set consisting of B, the set consisting of C. Those are the 1-element subsets. The 2-element subsets would be AB, AC, and BC. And there's one 3-element subset, ABC. Okay, now how many 0-element subsets are there? 1. How many 1-element? There are 3. There are 3 2-element subsets and 1 3-element subset. That gives us the numbers 1, 3, 3, 1, corresponding to the 3-flip row of Pascal's triangle. Okay? Now, what's the correlation between flipping a coin and picking subsets? Well, let's go to the set A, B, C, D, E, 5-element subset. Now, there are 32 subsets, and you could list them, and hopefully you could list them in alphabetical order and systematically in order to get all the subsets. Be a little bit challenging clerically to do that, but the idea is not difficult. Well, I'm going to select a subset, okay? I've got 5 slots here. I've got a slot for A, a slot for B, a slot for C, a slot for D, and a slot for E. And I'm going to flip a coin to determine whether I'm going to include A in my subset. So I'm going to flip the coin. I get heads. Okay, so I'm going to include A. So I'm going to put a check mark on A. Now I'm going to do another flip. Okay, I got tails. Now that was a flip for B. I'm not going to choose B. Flip again. I got heads. So I'm going to choose C. Flip again. Heads. I'm going to get D. And flip once more. I've got heads, so I'm going to choose E. Okay, by flipping the coin 5 times, I just chose the subset A, C, D, E. For every possible sequence of heads and tails, I'm going to get a different subset. That should be fairly obvious because I'm going to check a different set of slots. Okay, so selecting subsets of the set A, B, C, D, E is equivalent to flipping a coin 5 times. There are 32 possible outcomes, and those outcomes would go with the 5-flip row of Pascal's triangle, which is 1, 5, 10, 10, 5, 1. Okay, those would be the number of outcomes. There'd be one 0-element subset. Of course, that would be your empty set. There'd be 5 1-element subsets. And of course, A, B, C, D. It would be either A or B or C or D or E. There are 10 2-element subsets. You know, A and B, AC, AD, AE, BC, BD, BE, CD, CE, DE. List them. And we could list the 3-element subsets, the 4 and the 5. Probably easier to list what's left out of these two. So there's this one-to-one correspondence between the outcomes of flipping a coin 5 times and selecting a subset of this set. So that selecting subsets is very much an operation involving binary probabilities and binary counting. Now in class, I selected the set BCE in the same way. I had heads on the 2nd, 3rd, and 5th flips. I got BCE. Then I did this video, but forgot to hit the record button, so I did this one. Okay, didn't do this one in class, but I got tails on every flip except the 3rd, which gave me the subset C. Now, if we want to know the number of ways to get 3-element subset, it turns out that that is 5C3. It's the same as the number of ways of getting 3 heads on 5 flips. Okay, there are 5C3, which is 15 ways to get 3 heads on the 5 flips. And that each one of those gives me a different outcome. And I said 15. Let's see. 5C3 is 5 times 4 times 3. And that's 10, okay, over 3 times 2 times 1 gives you 5 times 4 divided by 2, 10 ways. I said 15, but that didn't match up with what I said over there, so I wanted to check myself. Anyway, the 5C3 ways to get a 3-element subset corresponds to the 5C3 ways to get 3 heads on 5 flips. Now with this information, you should be able to answer the remaining questions on the worksheet for today, and all those use exactly the same reasoning, just with different numbers than the ones we've seen in these examples.